A pictorial view of part of a car dashboard is shown in Figure 1. An exploded 3D graphic is also shown. So part A of the question asks us to draw an elevation in the direction of arrow A, looking in from the front here. Part B asks us to project a plan from this elevation. Part C asks us to project an end view in the direction of arrow B, that's looking in from the side here. And part D asks us to determine the true shape of surface S, the surface. So starting with part A in the question, draw an elevation in the direction of arrow A. Now the position of my elevation on the page is going to be determined by which direction my end view is looking in from. So my end elevation in this case is looking in from the right hand side, therefore the end elevation will be positioned on the left hand side of the elevation, so I will keep my elevation towards the right hand side of my page. So I'm going to start by drawing a rectangle that fits around the shape of this elevation. So the total width of that rectangle is going to be 95 plus 55, which is 150 wide, and high it's going to be 82 plus 50, which is about 132 millimeters high. So I'm going to draw a rectangle on that page of that size. So for the edge, or the left hand side of my elevation, I'm taking a vertical line up the page and measuring a distance of 132 millimeters. Taking that line horizontally across. And the full width of my elevation, I said, was 150 millimeters high, or wide. So putting a mark here on 150. So this rectangle which I have drawn on my page will fit around the outline of my elevation in the question. So next I'm going to mark in all of my horizontal heights up the page. So I can see here from the base, the first distance is up 20, the next one is up 20 again, the next distance is up 82, 50, and 50 millimeters. So I'm going to mark in all those horizontal distances on my page. So the first distance was 20, then 20 again. The next was 82 from the base up, and that left me with 50 millimeters. So I can take all of those lines horizontally across the page. I'm going to take them all the way across to my end elevation because I'm going to need them over there in a minute. Taking all of these distances horizontally all the way across the page. And extend the top line also. Right, and I'm missing one line on my drawing, which is this line here, which is 18 millimeters above the 82 millimeter line. So if I measure up a distance of 18 millimeters from this line upwards, that is going to give me all of the horizontal distances that I need for my elevation. Next, looking at the vertical distances, I'm going to take these distances across here. So my first distance in is a distance of 8, 34, then 8, over a distance of 95 to the center of this curved part. So I'm going to mark those distances across next. So the first distance was 8, second one was 34. I'm going to go 8 again, and we had a line that was 95 millimeters from the end. I'm going to mark all of those vertical distances all the way down my page, as I'm going to need those distances in my plan in a minute. So next I'm going to go over the lines which I know are heavy in my elevation. So the outline around the outside of my elevation. I'm going to use a black pen for this. You'll be leaning heavier on your pencil. So this point here on my drawing gives me the center for a curve which is radius 30 millimeters, and the smaller circle on the inside is going to be radius 10. So we're going to mark both of those in. So from that center point, I'm going to measure over a distance of 10 and 30. I'm going to set that distance on my compass. So the smaller radius, the radius 10, goes all the way around. And the bigger radius, the radius 30 millimeters, just goes 180 degrees from the same point. This slot at the front of the elevation cannot be seen from the elevation, but we have to show that it is there using hidden detail. So we can see that from this line that was 20 millimeters up at the start, and that's that top surface, it's down 5 millimeters from that. So on my drawing, I'm going to measure down a distance of 5 millimeters from the top. Take my line horizontally across, and using a broken line or a dotted line, this will show that there's hidden detail, that there's a slot in behind that front edge cut out. And that is all the information I can draw from my elevation for the meantime. Right, so there's a line on my drawing on this surface S here that I cannot locate yet. I'll have to draw it in plan and elevation before I can locate this line on my elevation over here. For my plan, I will be required to project down the outside of the smaller cylindrical shape here at front, and these two edges also. So project down the outside of my radius 10 circle, the outside of my radius 30 circle, as I will record these distances in my plan. To start my plan, I'm going to step down a distance of 10 millimeters from my XY line and draw a horizontal line across the page. Looking back to my drawing, I'm going to measure off all of these horizontal distances onto my plan. So the first distance down is 20, the second is 30, will take me to here, then 25 will follow the line down, will take me to this point, over a distance of 20, 10, and the radius of this is a distance of 25, so 25 onto that. So I need to step all of these horizontal distances down in my plan. So the first distance is 20. My next distance is 30, 25, 20, 10, and finally 25. I can step all of those horizontal distances across my page. So now I can start going over the outline of my plan from what can be seen heavy on the page. You can see on my drawing, I can see that to locate the position of this point here, I've come down 25 and over a distance of 10. So on this line here, I'm going to measure in a distance of 10 to locate that point. Sorry, the next line down, this line here, it was the line 25 down. And I can join that back diagonally. That'll give me an edge view surface S. You can measure halfway in on this 50mm mark to get the center for my radius. It's radius 50, or radius 25, sorry. Draw that in using my compass. This semicircle on the inside of the plan is in line with the line 8mm in from the edge. So I can draw in this radius using the same center as before. So setting the point of my compass down here, setting my radius in line with the radius 8 line, I can draw in that radius all of the way around. Over the line heavy from there to there. For this cylindrical shape at the front here is going to appear a distance out of 5mm out from the front face here. So if I measure out 5, this front face, will allow me to put that in heavy. And This curved section here in my elevation will be seen as an elliptical shape in my plan. So what I'm going to need to do is I'll need to produce an end elevation over here before I can put in that elliptical shape. So that's as much as I can do on my plan for the meantime. For part C of my question, I am asked to project an end view in the direction of ROB, so looking in from the right hand side. So on my drawing, if I take a line off at 45 degrees from the corner of my elevation, using a purple pen this time, I'm going to project each of my lines, my horizontal lines across from my plan view to that line. And take each of these lines vertically up the page. That will give me all of the lines required to draw in my end elevation. So I can go over the outline. So I've projected my lines across, straight across from my elevation and over to hit the 45-degree line for my plan, and then vertically up. Should give me all of the points that I need in order to draw in my end elevation, looking in the direction of ROB. So this point here is going to be joined as far as this point in my drawing, as far as this line, which is this line here on my drawing. So follow it over, sorry, this top line here. To find the top and bottom points of the cylindrical shape on my end elevation, I need to project them over from my elevation. So that is going to be this point here and this point here, projected across to my end elevation. So if I follow the points up from here, straight up to here, it's going to give me that cylinder as I'm looking in at it from an end elevation view. So now we can join across from here. It's going to be hidden detail in behind that. I also have to project across my hidden detail for the slot cut in here. So if I take that across, I know that goes from broken line to show hidden detail. And I can join from this point here across to my point on top, which is here. From here to here. So that is as much information as I can put on my plan for the meantime. So next, to get the shape of the elliptical shape here as I look down on top of my drawing here in plan, what I'm going to have to do is I'm going to divide up the circle into an equal number of parts in the view, which it appears as a circle, which happens to be elevation, project those distances across to my end elevation and down to the 45-degree line and back across to my plan. So to divide up the circle into an equal number of parts, I'm going to use a red pen this time. I'm going to use my 60-30 degree set square. That's going to give me a series of points on the outside of my circle, which I'm going to index. Points 1, 2, 3, 4, 5, 6, and 7. I can project each of those points vertically down to my plan. I know the point 2 is going to be somewhere along this line. 3 is going to be somewhere along this line. 4 along this line. 5, and finally 6. 5, 7 marked in already. I do. Okay, so to locate these points on the curve, they're going to be on this edge here in my end elevation. I'm going to project them horizontally across to find out where they hit my end elevation. Point 2. So again, I'm going to index those points on my end elevation. So as I'm looking in from this direction, I'm going to see point 6 first and then point 2. So this is going to be the point 6, comma 2. This point here on the base is going to be, I'm going to see 7 first and then 1. So it's going to be the point 7, comma 1. Looking in here, 5 and 3 will be along the same line. I'm going to see 5 first and then 3. So 5, comma 3. And finally point 4 will be here on its own. So to locate those points in my plan, what I'm going to do is I'm going to take them back. Okay, I have this point already. So I'm going to take them back vertically down as far as the 45-degree line. So all of those points have been taken down to the 45-degree line and vertically across. So I already have my point. I can see my point 1 is going to be directly down here. This is going to be my point 1. This is going to be my point 7. Next line is the line 6-2. So where the line 6-2 crosses the line 2 coming down here is going to give me my point 2, and 6 coming down will give me my point 6. My point 7 here. The line 5-3, take it across, where that hits the point coming down from 3 and coming down from 5, give me the corresponding points. And finally my point 4 come down, take it horizontally across, and where that hits my line coming down from 4, it gives me 0.4. So just to avoid confusion, I'm going to index all of those points again. My point 1, 2, 3, 4, 5, 6, and 7. So it's going to form an elliptical shape. So what I'm going to do is join the points up lightly, okay, getting into a comfortable position. So going from point 1 through point 2 to hit point 3. So again, getting into a position that's comfortable for you to draw that, just lightly first of all. Form a gradual curve between each of the points. Once I'm happy with what the curve looks like, I can go over it heavy in a black pen. Or in your case, you lean heavier on the pencil. Or use a harder, heavier pencil. So that gives me my elliptical shape. Finally, in my elevation over here, I need to find the position of this point here on my elevation, how far across it is. So if I follow this line across, back up and over, that's this point here in my end elevation is going to be here. It just happens to be on the same point as line 6-2. If I extend that across a little bit further over, that's going to give me the position here to join. So I come straight up here. This point on my drawing here, in line with the edge, is joined back to this corner. And I located that from projecting it across from my end elevation. Finally, the last part of my drawing asks us to determine the true shape of surface S. That's this surface here. So there's two separate ways I can do that. One of the ways is I can rotate this line about until it's horizontal and locate it in my elevation, or else I can take an auxiliary view looking in at 90 degrees to this edge here and project my lines at 90 degrees to this line and take my heights from elevation. So for this particular question, it's probably easier to rotate it. Okay, it's a little bit quicker, so I'm going to use that method. So I extend this edge horizontal, and I will rotate that edge. Okay, it's the view in which I see the line as a straight edge. So I'm going to rotate that view around until it's here. So I'm taking that distance straight upwards. This point here, which I have rotated, is this point here in my elevation. So I'm taking that point directly straight up, in line with that line, hit here, and I can join that back. So that is what I've shaded in here is the true shape of my surface S, as seen here in my pictorial view.